I'm Anil Kumar, and here is a very interesting video on two equal composite functions. Now we have seen that if we start with two functions, then their composite functions are not commutative, right? What I'm trying to say is f of g is not always equals to g of f, right? So that is true most of the time, right? This is true most of the time, right? Now the question is, when is f of g equal to g of f? That is the question for you. When? So when is this? So when is f of g is equals to g of f? That is the question for you. Can you answer that for me? Well, this is one example I can surely give you. This is always true when g is equals to f inverse, and both are functions. Do you understand? So if we have inverse involved in it, then always they will be equal, right? And they will be equal to what? They will be equal to, then f of g will be equals to g of f, and both that composite function will be just x, right? That is the definition, and that helps us to find two equal composite functions. That's the whole base for what I'm going to do now, correct? So let's take some function. So we'll say f of x is equals to let's say 2x minus 1. Now I want to create another function so that the composite functions we could get equal composite functions. Now how can I do that? So that means basically I need to find inverse of this, right? So g of x inverse, we'll find inverse by reading it in the reverse operation. F of x is 2 times x minus 1. So if I add 1 and divide by 2, I should get inverse. So x plus 1 and then divide by 2. That gives me inverse of f of x, right? Now, some of you may not agree with me. So what we will do here is that we'll check it out, right? So we'll just check it out. So let us check. What is f of gx, right? So let's find what is f of g. Now when I write f of g, it really means f of g of x, right? This is what it means, correct? So let's calculate what is f of g in this particular case. So it should be equal to f of function is 2x minus 1. So I have to replace x with the g of x, which is x plus 1 by 2. So we can write first as f of x plus 1 over 2, and then we'll replace, okay. So we have 2 times x plus 1 over 2, that is what this is, minus 1, right? So if I open this bracket, I get this as equals to x plus 1 minus 1, and that is indeed equals to x. Since f of g is x, we know g is inverse of x. You get the concept, right? Well, let's do the other way also and then check it out, okay? So this time we'll start with g of f. Okay, so g of f, which really means g of f of x, correct? That means g of f of x is 2x minus 1. 2x minus 1. So that should be, I'll replace x with 2x minus 1. So we get 2x minus 1 plus 1 divided by 2, right? And that gives us 2x divided by 2, and that is also equals to x, right? So perfect. So what we got is what we expected. So in our example, since we found that g of x is indeed equals to f inverse of x, we found that g of f is equals to f of g, right? So that is probably the best example which you should be giving when it comes to two equal composite function, right? So we proved that f of g in our case was equals to g of f, and the key was their relation was like an inverse function, right? So inverse should be a function to get this type of result. So that is the key which we learned from this particular video. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.